Hello guys, welcome to our class for today. This is Nobel My Science Tutors Online and I remain Notable Michael. This is your physics video tutorial on YouTube. So for today we'll be looking at electromagnetic waves. That's what we're going to be discussing in this lecture. Remember that we have already discussed wave motion in our previous videos, on our previous lectures. So you can briefly review that video while we progress with this particular lecture. So as I've always encouraged, please get your writing materials ready. We are going to discuss briefly and also solve some problems. Okay, so for this particular class, we'll be looking at electromagnetic waves. We'll also discuss the electromagnetic spectrum. We'll look at the uses of electromagnetic waves, and then we'll solve some problems on electromagnetic waves. So please get your writing materials ready so that we can progress to this particular lecture. But before we move, if you have not subscribed to this channel, please subscribe to the channel. Click on the subscribe button. Also, if you have subscribed, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also tell your friends. You can share this video with your friends. Let them know that something is happening in YouTube. We are covering the complete physics curriculum, and so far we've covered a lot of topics, and now we are on electromagnetic waves. So if you have been following us and you enjoy what we're doing, please give us a thumbs up so that you can encourage us, right? Also help us to share the video so that your friends and your colleagues, they can have access to this information that is on YouTube. So welcome once again. I hope you have gotten your writing materials ready so that we can go straight to our class for today. As I've said, we are looking at electromagnetic waves. Alright, so please let's go straight to our class. Electromagnetic waves, EM waves. So what are EM waves? Remember that in our previous videos or our previous lecture we discussed wave motion, and when we discussed wave motion we talked about two types of waves generally, and that is mechanical waves and electromagnetic waves. And in that particular video we said that mechanical waves are waves that requires material medium for their propagation, and we listed some examples. Examples were water waves, sound waves, and waves in ropes and strings. So we know that water waves are generated because of vibration of water particles, while sound waves, they are generated because of vibration of air particles. So the water particles and the air particles, they are medium by which water waves and sound waves are propagated. Alright, but there's another class of waves that does not require material medium for their propagation, and those waves that does not require material medium for their propagation, they are known as EM waves, that is electromagnetic waves, and they arise from the vibration of either electric and magnetic fields. So by the time you combine the electric and magnetic field, you have what is called electromagnetic. Okay, so you have what is called electromagnetic, and this is what actually gave rise to that name, electromagnetic wave. And the typical examples of electromagnetic waves are light waves. We have light waves, we have X-rays and gamma rays. Okay, so these are typical examples of electromagnetic. There are other examples I will discuss as we progress in this particular video. So by the time we're looking at the electromagnetic spectrum, you see other types of electromagnetic waves. So what are some of the differences between electromagnetic and mechanical waves? One of the key differences is that electromagnetic wave travels at the speed of light, while mechanical waves, they don't travel at the speed of light. Is that okay? They travel at a lesser speed than the speed of light. That is one of the critical examples. Also, mechanical waves may behave either as a transverse wave or longitudinal wave. So a mechanical wave could be either water wave or sound wave. Alright, but electromagnetic wave, they are always transverse in nature. So these are basically the difference between mechanical wave and electromagnetic wave. Alright, so we'll look at the electromagnetic spectrum so that we see other types of wave that makes up the electromagnetic wave. Okay, so we'll see other type of radiation that make up the electromagnetic spectrum. Apart from light waves, X-rays and gamma rays, we'll look at other radiations that make up the electromagnetic spectrum. So if you remember our discussion, we discussed dispersion of light. We mentioned briefly this electromagnetic spectrum. Okay, so the electromagnetic spectrum consists of series of radiation which are arranged in order of decreasing wavelengths and order of increasing frequency. So in the electromagnetic spectrum, which is depicted, which is in this picture, we have radio waves which have the highest wavelength of about 10 raised to the power 3 meters, or about 1000 meters, and then we have the gamma rays which have the lowest wavelength of about 10 raised to the power minus 12, and that's what you can see here. This wavelengths, they are from radio wave down to gamma ray, they are arranged in order of decreasing wavelength. Okay, so then if you look at the frequencies, you will see that the frequencies, they are arranged in order of increasing frequency. Radio will have the lowest frequency, while gamma ray has the highest frequencies, and in between you have the microwaves, the infrared ray, the visible light, which is the visible spectrum. Then you have the ultraviolet, the X-ray. These are the waves that are, all the radiations that are in between. So the visible light consists of the 7 colors of light. You remember we discussed this, and they were depicted or abbreviated as ROIBIV. Okay, so we have the 7 colors of light that makes up the visible part of this electromagnetic spectrum, and that is what is depicted, or what is here in this particular picture. Okay, so from this you see that radio will have the highest wavelength and gamma ray has the lowest wavelength, and radio will have the lowest frequency, and then gamma ray has the highest frequency, and that you can see in this arrow indication. This arrow indicates that the radiation arranged in this order is in the order of decreasing wavelengths, and then the order of increasing frequencies. Okay, order of increasing frequency. So if you look at this order, we will see that the gamma ray has the highest energy, while radio waves has the lowest energy. Okay, so please take note of this. These are typical questions that you can be asked in your either in your JAM or WAEC examination. These are objective questions that you can actually be asked. So you just need to take note of this and know that radio will have they have the highest wavelength, gamma ray has the lowest wavelength, and radio will have the lowest frequency, and the gamma ray has the highest frequency. And along the radio wave you have other frequency. You have ultra high frequency and other that are used for broadcasting of and also for communication in radio houses. Okay, so that is just the electromagnetic spectrum. All right. So we have looked at the electromagnetic spectrum. So in this particular part, we look at the formula for the wavelength and then for the velocity of light. So we have seen that the spectrum of radiation makes up the electromagnetic waves, and all this way they travel at what? The speed of light. And the speed of light in vacuum is equals to 3.0 times 10 raised to power 8 meters per second. Alright, so and speed of light is represented by the letter C. We also want to remember that just like any other wave motion, electromagnetic wave has the same characteristics of light waves. They exhibit the properties of light waves such as reflection, refraction, interference, and then diffraction. So electromagnetic waves all behave like light wave. You need to take note of that. Okay. The only major difference between the wave that we have seen is in their frequency and their wavelength, and also another difference in their mode of production and detection. So they are detected by different methods, and also they are produced by different methods, but they exhibit the same characteristics of light, and then they are different by way of their frequency, which we have discussed, and their wavelength, which we have also discussed. So we want to remember that when we discuss wave motion, we have the wave equation to V, velocity of wave, to be lambda F, right? Now for electromagnetic wave, V is represented with C. Alright, so this equation becomes C is equals to lambda F, and lambda, which is wavelength, equals to C over F. Okay, so with this equation we can solve for the wavelength of this radiation that we've just discussed, or we can also use this equation to get the velocity of wave. We can use one to find the wavelength of the wave. Then we can also use F is equals to C over lambda, as the case may be, to find frequency. So depending on the question that you are giving, when we are talking about electromagnetic wave, you can use any of these equations to solve for your variable that you are looking for. Alright, so please take note of this equation so that you know when and how to apply them. We'll definitely solve some problems as we progresses, but just take note of these equations. Okay. Alright, so as I just said, this is a typical equation that you can use that a typical question that you can use those equations to solve. So this question says that a radio station broadcasts at a frequency of 2000 kilohertz. Calculate the wavelength of the radio waves produced. Okay, take C is equals 3 times 10 power 8 meters per second. So in this particular question, you are given a frequency to be equals to 2000 kilohertz. Okay, so if this is 2000 kilohertz, before you solve, you have to convert it to hertz. So if you want to convert this to hertz, you have to multiply it by 1000. So by the time you multiply this by 1000, you are going to have 2000 times 1000. Okay, so this will give you 2 times 10 raised to power 6 10 raised to power 6 hertz. Okay, so that is what you will have when you do that conversion. Then you are given velocity of light C is equals to 3 times 10 raised to power 8 meters per second. We have said that you are looking for wavelength from C is equals to lambda F. Lambda is equals to C all over F. So just substituting into this equation, you have 2, you have 3, you have 3 times 10 raised to power 8 meters per second, all over 2 times 10 raised to the power 6 hertz. Your answer will be in meters. Wavelength is measured in meters. So by the time you do this division out, you're going to add that your wavelength is equals to 150 meters. So you can punch your calculator and get that. So basically, these are majorly the kind of question that you will see when you're talking about electromagnetic waves. Okay. So as I said, what are some of the uses of electromagnetic waves? Okay, so we have seen the radiations in the electromagnetic waves. So what are they used for? Why are they important? Why do we discuss them? Why is it important we should know them? And why should we be discussing them? So that's what we're going to do. That's what we're going to discuss now. What are some of the uses? One, radio waves. Radio waves, they have the highest wavelength and lowest frequency. And what are they used for? They are used for radio transmission. Okay. So radio has this, it makes use of radio waves to transmit and broadcast radio informations. They are also used for TV communication. So your TV and radio stations, they use radio waves to broadcast to us. That okay? So those are the use of radio waves. The microwaves, they are used to detect the presence of enemies. You have in most homes these days, the average home, they have a microwave cookers. So you have microwave at home. So they are used for cooking and preservation of food and for detection of enemies. Okay, then infrared. Infrared, they are used to dry paint in automobile. They are also used for cooking, and they are used for your remote sensor. Your remote controller actually work by infrared radiation. Okay, your remote controller works by infrared radiation. Then we'll have the visible light. The visible light, as I said, consists of the 7 colors of light. That is red, orange, yellow, green, blue, indigo, and violet. So they are used in photographs and then for seeing objects. Okay, that we discussed before when we discuss the spectrum of light. Then we have the UV rate or the ultraviolet rate. They make materials to fluorescence, that they make materials to glow, and they are also used to produce vitamin D in human body. You know, that's why they say stay in the sun for some time. Early morning sun in the morning. It is for your body to absorb UV radiation. Then we have X-rays. X-rays have high penetrating power, and as such they can penetrate through bones and bricks. They are used in the hospitals for X-ray pictures or radiographs of bones and internal body organs. They are used for the detection of flaws in materials and welding joints. So sometimes if you are used to welding, you see after welding they will do what is called X-ray radiography. Radiography is to check if there are cracks in the welded joints. Okay, so they are used to detect faults or flaws in welded joints. They are used to study crystals, structure of crystals and structures of atoms. And in the airports, they are used to scan concealed weapons in luggages. Okay, so these are some of the uses of X-rays. Then what about gamma rays? Gamma rays, they have the shortest wavelength and highest frequency. Okay, and they penetrate more than X-rays. In fact, the penetrating power is, according to studies, about 1,000 times that of X-rays. So what are they used for? They are used in the medical field to sterilize medical equipment such as surgical equipment, drugs, food, and etc. And they are also used to treat cancer and tumor. Okay, they are also used to treat cancer and tumor. So these are some basically the uses of electromagnetic waves. All right, so these are the uses of electromagnetic waves, and I hope this lecture is clear for you, and then we'll look at some questions that you need to answer yourself. So this is your test your understanding page. I want you to answer these questions on your own, right? Answer this question on your own and then solve this problem that is here. These are simple questions, and all these questions, they are called from past WAEC questions and JAM question. This is basically a JAM question. This is a WAEC objective question, and this is also a WAEC objective question. So all the questions that are posed in my test your understanding, they are all either WAEC questions or JAM questions. Okay, so that's why I always encourage you and advise you to please solve these problems on your following the examples that I've done for you, so that you have you have a strong grip of what you are learning and get a better understanding. Besides that, please don't forget your textbooks, right? Have your textbook as a companion. It's a major text. What we are doing is just like we're trying to make you understand better what you read in your textbooks. Okay, so please don't play with your textbooks. Read your textbooks, combined with the video that you are watching for you to get a better understanding. We want you to have a better and clearer knowledge of physics, so that we can remove the fear, because for most students it's fear that means they don't want to offer science subjects, especially physics, because of the mathematics that is involved. But if you follow through all our videos, you find out that physics is basically just understanding of principles and then application of the principles. If you can have a basic understanding and you know how to apply the principle, it comes out very simple and easy for you. Okay, so thanks so much. This is where we're stopping for this particular class. But before I leave, please, if you have not subscribed to our channel, please, what are you waiting for? If you enjoy what we're doing, give us a thumbs up, give us a like, give us positive comments, subscribe to this channel. If you are just visiting this channel, please subscribe. It can also help us to share this video with your friends, ask them to come and subscribe. Is that okay? You can reach us right at the WhatsApp number that is showing on your screen. You can also click on any of our video links and it will take you to our WhatsApp page. Okay, so thank you so much. We appreciate you for being with us. We promise to make physics a better subject for you to understand. So I remain Notable Michael, and we hope to see you in our next video. Thanks.